We are given an array of positive integers,
Yeah.
positive numbers. We're also given a number k. We need to take exactly k numbers from the array, from the beginning or the end, right? So we want to maximize the total numbers taken, right? So given this example, like look, we want to take 3 numbers. So let's take each number, one number at a time. The first number we can take is this one or this one, right? So it doesn't matter. So we can take, for example, take this one. The points we've taken is 1. So if we take this number, so the next number we can take is this 2 or this 1, right? So for example, we can take this one, right? Take this one. Then the numbers will be 2, 3, 4, 5, 6 left. So we
2
can
or 6.
we can choose 6, yeah? So the total number we have taken is 8. We can take the numbers from the beginning or the end. And we want to maximize the total number taken. Okay?
Yeah.
So if given this example, what's the maximum number we can take?
12. Because 165 at the end.
165. Okay, so what's your strategy? Why is it 561?
Because you need. Because you look from the beginning and the end. They're both 1, so you could. So first you need to have 1, and then if then you choose the next one is 2 and 6. You always choose the biggest one out of those. So 6 is it, and then 3 or 5, so it's 5.
Okay, but look, this is both are 1. So how do you decide which one is taken?
Because I just look visually and cut it in half because these numbers are bigger than these numbers. Because these numbers are bigger than those. This
Yeah.
is value 6 and this is value
I see, I
12.
see. But how do you, I mean, this visual, I mean, this might be a simple example in which you can tell, you know, like your guess, the hunch, yeah?
A hunch.
A hunch.
Just a hunch.
Just a hunch. You look at it, okay, you say, okay, maybe it's better we pick from the right, so you keep doing from the right
No,
hand side.
it's just because you just cut in half and just these numbers are less,
Right, I
some
see.
left than these.
Okay, okay, this is one, yeah, I got it. But,
Pretend that 4 is the separating those.
okay, so let's put it this way. If we want to prove false, how do we prove false?
We check every possibility.
What's the each possibility? Yeah, what's the each possibility? So
Each numbers.
there are k numbers to take, right?
Yep.
At each point, how many choices do we have? Come on, that's a simple 2, yeah? We can pick from the beginning or the end. There are two choices. So the k numbers, we want to pick k numbers, and for each number we have 2 choices. So what's the time complexity? How many choices total?
Okay.
2 to the power of k. Let's think of it this way. All the numbers could be at the beginning, or all the numbers could be at the end. All the mixed. So some numbers at the beginning, some numbers at the end, right? What's the opposite? Look, we want to pick the numbers and maximize the numbers. What's left? Look, suppose, we could have some numbers left. This is subarray, sublist. So what's the opposite? We want to pick some numbers from the beginning, combine, you know, from the beginning or at the end. So what's left? Left is the green bit, okay? It could be any green bit, right? But it has to be continuous subarray, right? We want to maximize the numbers that are not a green bit. We want to maximize, look, suppose this sum is S. S is the sum of the ARI, okay? ARI, okay, that's ARI from I equals 0 to n minus 1, right? So this is the sum of the total array, right? This is, we know it. We can calculate it in one go, going through all the numbers, sum of all the numbers, right? Sum the numbers. The green bit is the sum of any continuous subarray. So what's the numbers that are not the green bit?
1, 6.
1.
So that could be one choice. We want to maximize the black bit. The total sum is fixed. The black bit plus the green bit is the S. So we want to maximize the black numbers. This is, the green bit is A. So what's the black bit?
S minus green bit.
Is A, right? This is the number we want to maximize. We want to maximize this. S is fixed, we know it. It doesn't change. So what do we do with this A?
Make it smaller, least.
So what does it mean? What's the opposite of maximize?
Minimize.
Yeah, so we want to maximize this. S is not changed, it's a sum, yeah, of every numbers. So A needs to be minimized. So we want to minimize this A, right? Now, A is continuous. We want to minimize it. Look, K equals 3. We want to pick 3 numbers of the black bit. What's the size of the green bit? There are total n numbers. And then there are k numbers we want to pick. So what's the size of these?
N minus k.
N minus k. So n minus k, this is continuous, yeah? What can we do with this? There are n minus k, 4 numbers. What's this?
2 pointers.
Yeah, 2 point sliding window. Look, 10. What's the sum of these? 2 plus 3 plus 4 plus 5.
14.
Okay, what's the sum of these?
18.
Okay, look, the beginning, 10. 14, yeah?
18.
18. 16.
16.
All the numbers added together. What's the sum? Be quick.
22.
22. We want to maximize 22 minus a. We want to minimize this a. So what's the minimize?
10.
10. We want to pick the 10. So what's the value? 22 minus 10. 12. 5 plus 6 plus 1. Yeah, so can you explain to me what I'm doing here? What I'm doing here?
It has to be a connected block. It can't be separated, and you just move it to get the least value number. So A has to be the minimized to the least value.
So we give an array of numbers, and we want to take k numbers from the array. At each number, we can take from the beginning or from the end at the end. So we want to maximize the numbers taken. So if we go for a brute force, we can take, for each number, we can take from the beginning or at the end. There are 2 choices. And for k numbers, there are 2 to the power of k. That's exponential, which is very slow. So we can think of it the opposite way, right? So we want to take k numbers from the beginning or the end. So
What
there are
if
only
k is bigger than the numbers of the card points?
good point. So we just take everything, right? Am I right?
But I haven't took k numbers.
Good point. You can't take more than k numbers. That's obvious. When we take k numbers, what's left is a subarray. Right? It's a continuous subarray. So we want to minimize the sum of the the remaining numbers, right? Because the total number, the sum of the total numbers is not changing. The sum of all the numbers is not changing. Minus the remaining part would be the sum we are trying to maximize, right? So look, s minus a. We want to maximize these. So s is not changing, right? S is given as a constant. Yeah, all the numbers we know for sure. All the sum of all the numbers. So we are trying to minimize this bit, right? So how do we minimize this bit? We want to take k numbers, and there are n numbers, so there are n minus k numbers left. So the size of the window is n minus k. So we're just using the sliding window, yeah, to calculate the minimum sum of the sliding window. Okay. Array k numbers, n equals length a, window equals sum of a up to, what's the size of the window? N minus k, right? So size would be n minus k. At the beginning, we want to go to the n minus k. This is the index, right? So we need to move this to the n. So while I is smaller than n, we want to find the minimum, right? Minimum of a. So ma equals, at the beginning, it will be the sum of it. So wind. Okay? A, B, C, D. If the size of window is 4, right? When we move the window to the right, 1 position to the right, what happens to the sum? It becomes what?
It's
Becomes B.
minus A and plus E.
Yeah, plus E minus A, way down. Yeah, plus E minus A. So look, when we move this, win plus equals the AI, and win minus equal A. Now it's I. What's the size? I minus n minus k. Right? And then we need to minimize this. Minimize of the window. And then I plus equals 1. And return. What's the sum? Sum of everything. Minus ma. So 1, 2, 3, 4, 5, 6, 1, right? That's the array. A equal that, k equals 3. So what happened? What happened?
So win equals sum A dot
n minus k. So what's win?
win is window, and n minus k is a window. So this is k. A minus k is 4. Right now.
Yeah, 4. Okay, so win equals what?
4.
What's the size of the window?
4.
Okay, so sum A up to 4. What's the sum?
10.
Yeah, okay, so that's right. The window here is 10. Okay, so now I will be equals to 4, right? So 0, 1, 2, 3, 4. I will be here. Why we haven't reached the end? So window plus AI, so plus 5. But we need to minus what? 1.
Yeah.
The next iteration, add this number minus this number, add this number minus this number. Okay, when now I goes to the end and we break this, the sum of all everything will be 22. The minimum A will be 10 at the beginning. The last question, what have you learned today? What's the time to next week?
ON.
Yes, ON. Why is it ON?
Because you need to go through, you know what?
Goes through what? What?
Go through the n.
Yeah, it goes through all the numbers.
So you have this A, right? You can take one from the front and next from the front and back.
Yes.
And so, yeah.
So how do we solve this problem?
Brute force, 2 pointers.
Okay, so what's the brute force? How do we brute force?
By checking every possibility.
What's each possibilities?
The window, no, I mean the k.
Yes, for each number, how many choices?
2. O2k.
2 to the power of k. What's the sliding window?
So you have this window. It is the size of n minus k,
Yes.
and so we basically move it
Yeah.
and to get minimize the window.
Why do we want to minimize the window?
So your score can get the highest.
Yeah, because we want to maximize the remaining. So we need to minimize the bit. We want to minimize the subarray, so the rest will be maximized, right?
Yeah.
Okay, the time can next the OM because we're going to the arrays. Once we update, look, be here to update the sum of the window. So every time we move one element, move the window one to the right. So when we take the new number, we discard the leftmost number. Am I right? That's the sliding window thing. Okay, that's it for today. Bye bye.
Bye.